Hello guys, welcome to my channel. So as you know, we are studying about the protein function, right? And we studied about the hemoglobin and myoglobin. So we are still discussing about the protein function, and before we move further into the protein function, but there's one more thing, that if hemoglobin binds to that substance, it can be fatal to our lives, right? So there is a history, like in 2000, in Arizona Lake Powell, there was a family was vacationing on a rented houseboat. What they did, they turned on the electrical generator to power an air conditioner and a television. Right, about 15 minutes later, two brothers, aged 8 and 11, jumped off the swim deck at the stern. Situated immediately below the deck was the exhaust port for the generator. But within just 2 minutes, both boys were overcome by the carbon monoxide in the exhaust, which had become concentrated in the space under the deck. Both drowned. Right? So, this death, along with this series of deaths in the 1990s that were linked to the houseboats of that kind of design, eventually led to the recall and redesigns of the generator's exhaust assembly. So here we are talking about carbon monoxide, that they died because of the carbon monoxide. Carbon monoxide. So what is carbon monoxide? Carbon monoxide, a colorless, odorless gas. Right? So can I write it down here? Colorless, odorless gas. Right, colorless, odorless gas is responsible for more than half of yearly deaths due to poisoning worldwide. And carbon monoxide has almost approximately 250-fold greater affinity for hemoglobin than does the oxygen. So affinity is 250 times greater than oxygen, right? So consequently, relatively low levels of carbon monoxide can have substantial and tragic effects. When carbon monoxide combines with hemoglobin, the complex is referred to as the carboxyhemoglobin, or also known as COHB, right? So carbon monoxide combines with hemoglobin, what's that known as? Hemoglobin, that is known as carboxyhemoglobin. Or also in short COHB. So generally carbon monoxide, if you know, it's a natural process, but locally high levels generally result from only from human activities, like what we do, like engine, furnace, exhaust are important sources, as carbon monoxide is a byproduct of incomplete combustion of fossil fuels. In United States alone, nearly 4,000 people succumb to the carbon monoxide poisoning each year, both accidentally and intentionally as well. So many of the accident deaths involves undetected carbon monoxide buildup in the enclosed spaces, such as when the household furnace malfunctions or leaks, venting carbon monoxide into a home. But however, carbon monoxide poisoning can also occur in open spaces as well, as unsuspecting people at work or play inhale the exhaust from generators, outboard motors, tractor engines, recreational vehicles, or lawn mowers as well. Right, and the carbon monoxide levels in the atmosphere are rarely dangerous, but it's ranging from less than like uh, 0.05 part per ppm. That's part per million, right? In remote, but this is in remote, and there is uninhabited areas as well, so where there should be like 3 to 4 part per million in some cities of northern hemisphere. So in United States, the government mandated the limit for carbon monoxide at work sites is 50 ppm for people working an 8-hour shift. So the tight binding of carbon monoxide to hemoglobins means that the COHB can accumulate over time as people are exposed to a constant low level sources of carbon monoxide. So in an average healthy individual, 1% or less of the total hemoglobin is complexed as COHB. So in an average, how many what's the percentage? In an average, 1% or less. 1% or less of the total hemoglobin is COHB, right? So since the carbon monoxide is a product of tobacco smoke, many smokers who smokes have the COHB. Smokers have this COHB. And what's the percentage? The level is in the range of 3% to 8% of total hemoglobin, and this level can rise to 15%. Can rise to 15% in chain smoker. For chain smoker, right? And this carboxyhemoglobin (COHB) levels equilibrate at 50% in people who breathe air containing 570 ppm of carbon monoxide for several hours. So how it equilibrate, how it goes to 50%? If someone is breathing air that contains 570, not this 3 to 4, but 570 per part per million of carbon monoxide for several hours. So there is reliable methods have been developed that relate carbon monoxide contained in the atmosphere to carboxyhemoglobin levels in the blood, right? So in the test of houseboats with a generator exhaust like the one responsible for the Lake Powell deaths, the carbon monoxide level reached 6,000 to 30,000 part per million under the swim deck, and the atmospheric O2 levels under the deck declined from 21% to just 12%. Even above the swim deck, the carbon monoxide levels of up to 7,000 ppm were detected, high enough to cause death within just few minutes. So now how the human is affected by this carboxyhemoglobin, by this binding. So like at the level of less than 10% of total hemoglobin. So less than 10% of total hemoglobin, this COHB complex, right? Symptoms are rarely observed. There will be like very less symptoms, or like it cannot be observed at a 10% level. But when it increases at 15%, the individual experience mild headache. So this will have mild headache. When it rises to at like 20 to 30%, so what will happen? The headache is severe now and is generally accompanied by nausea, dizziness, confusion, disorientation. Alright, so we'll write it down here. So it will have severe headache, nausea, confusion, dizziness, disorientation, right? And sometimes visual disturbances as well. And these symptoms are generally reversed if the individual is treated with the oxygen. But at the carboxyhemoglobin level of 30 to 50%, when this reaches to 30% to 50%, the neurological symptoms become more severe. What will happen at this level? Neurological symptoms will be more severe. At this level, neurological symptoms will be more severe, and at levels near 50%, the individual can lose consciousness and can sink into coma. Respiratory failure may follow, and if with the prolonged exposure, some damage becomes permanent. Death normally occurs when the carboxyhemoglobin level rises above 60%. If this rises above 60%, then it will cause death. Right? Autopsy on the boys that died at the Lake Powell revealed this UHB level of 59% and 52%. And binding of this carbon monoxide to hemoglobin is affected by many factors, including exercise and change in air pressure related to the altitude as well. So because of their higher base level of COHB, smokers are exposed to a source of carbon monoxide often develop symptoms faster than this non-smoker. So if smokers are exposed to the COHB levels, like if it's just even low at 10%, for example, if it's just 10%, the smokers can be affected more than this non-smoker. Individuals with heart and lung diseases or blood diseases that reduce the availability of oxygen to the tissues may also experience symptoms at the lower level of carbon monoxide exposures. And fetuses are particularly risk for carbon monoxide poisoning because fetal hemoglobin has somewhat higher affinity for carbon monoxide than adult hemoglobin. Right? And so this is it may be seem surprising that the loss of half of one's hemoglobin to this COHB, carboxyhemoglobin, can prove fatal. Why? We know that the people with any of several anemic conditions manage to function reasonably well with the half the usual complement of active hemoglobin. But however, the binding of this carbon monoxide to hemoglobin does more than remove the protein from the pool available to bind oxygen. So what it does, it also affects the affinity of remaining hemoglobin subunits for oxygen. Like as we know, as carbon monoxide binds with one or two subunits of hemoglobin tetramer, the affinity for the oxygen is increased substantially in the remaining subunits, right? Thus, a hemoglobin tetramer with 2-bound carbon monoxide molecule can efficiently bind oxygen in the lungs, but it releases very little of it in the tissues. So what happens? So for example, like we know there are 4 subunits of hemoglobin. So if this 2 are taken by the carbon monoxide, right? So this 2 will have the higher affinity for oxygen, O2, but the thing, because as this has just carbon monoxide, so the affinity to release the oxygen in tissue will decrease, and that's where the problem starts, right? So that means the oxygen deprivation in the tissue rapidly becomes more severe. And to add to this problem, the effects of carbon monoxide are not limited to interference with hemoglobin function. It's just not that it's just interfere with the hemoglobin function, but carbon monoxide binds to other heme proteins as well, and a variety of metalloprotein too. The effect of this interaction are not yet well understood, but they may be responsible for some of the long-term effect of acute but non-fatal carbon monoxide poisoning. So when carbon monoxide poisoning is suspected, rapid removal of a person from the carbon monoxide source is essential, but this does not always result in rapid recovery. When an individual is moved from the carbon monoxide polluted site to a normal outdoor atmosphere, oxygen begins to replace the carbon monoxide in the hemoglobin, but this COHB level drops only slowly. The half time is about, what's the half time? Half time is about 2 to 6.5 hours. So that's the half time depending on individual and environmental factors. So if 100% oxygen is administered with a mask, the rate of exchange can be increased about 4-fold. So the half time of oxygen to carbon monoxide exchange can be reduced to tens of minutes if 100% oxygen, like at which pressure, at almost like 303 kPa, kilopascal unit, is supplied. Thus, rapid treatment by properly equipped medical team is critical, right? And that is the reason carbon monoxide detectors in all homes are highly recommended, right? So this is a very simple and inexpensive measure to avoid possible tragedies. So guys, if you don't have carbon monoxide detectors in your house, you should definitely buy some, right? This is why carbon monoxide detectors are really very important, right? Thank you guys for watching, and don't forget to subscribe the channel. Thank you. We'll see you with the next topic. See you.